Professor, hey class, this is Kevin Rappa. This is my submission for assignment 3. So I just finished calibrating the propeller and everything, and I got everything hooked up, although probably not going to use the propeller to demonstrate this in the video because I would need 3 hands for that. I have only 2. But anyway, so in doing this, I've started with this diagram to hook everything up. I pretty much did it just how this diagram stated. Although 150 ohm and 3000 ohm resistors did not work for me. These like addendums here did, so I used the 330 and the 10,000 ohm resistor, and that worked. And I did have to point the bulbs like right at each other, but once I did that, it pretty much worked like a charm. So yeah, I hooked it up just like here. I fed the analog wire, the wire for the analog signal, into A0, which undergoes a digital conversion. I think the A1 might as well. I don't think all of them do this, all the analog inputs, but I know A0 does. But anyway, I don't really think there's much else to say about this because I don't think I really did anything special. I might hook up the buzzer just for fun, just to see like what it might sound like when I put the propeller in there, but yeah, it just outputs to the screen. So going over the code, you can see it's currently like printing values every second. So I'm going to put my finger in here and start like flapping it, and you'll see that it does increase. And with my finger alone, I haven't been able to get it to go above 16, but I put the propeller in here very carefully, and I got it to go up to like 100 before I felt it was unsafe. But yeah, then I'll stop right there and nothing. So I think it works pretty well up to the amount I tried, which was like at 100 revolutions per second from the propeller. So it seems to be working pretty well. So anyway, just going through the code, like I mentioned earlier, I'm using the IRQ for the analog digital conversion. So every time there's an analog, I think the port might be sampling the analog value and converting it to a digital value. So I set up a threshold of 500 that I just got from in situ testing, and I'm just checking if that signal is above or below it. So if it's above it, then something is in front of the LED, and if it's less, then there's nothing in front of it. So I'm just using that to set a flag whenever it goes above the threshold, but not below. So let's see, this one is for a timer. I just used the 1-second timer from my previous assignment, and I'm just setting a flag every second. So it's just that simple. And I just have a bunch of setup functions for setting up, this is for setting up the timer, and then this is for setting up the analog to digital converter right there. Some more setup stuff, and then right here is the loop, which does the round robin. So these functions right here check a flag, one for the timer, one for the analog to digital conversion, the ADC. And every time there's a conversion, it just increments a number. And then every second, I'm just reading that and resetting it to 0 and then printing it. So it's printing in hertz, or I guess revolutions per second. So that's pretty much it. Thanks for watching.